So suppose we're saving up for a down payment for our first home, right? And mortgages or mortgage companies are going to expect a 20% down payment on a mortgage, so we need to save up that amount. So let's say in our area, a typical starter home is like $300,000, and we want a 20% down payment for that. And I want to figure out how much I need to invest now so that in 5 years I will have that down payment. Okay, so this is kind of going to be 2 steps. One is figuring out how much of a down payment I need, and then figure out, well, how much do I need to invest now? Okay, so the down payment is 20% of $300,000. So it'll be 20% of $300,000. Hopefully by this stage of the course we know how to do that. That's just going to be 20 over 100 times 300,000, or just 0.20 times 300,000, which gets me $60,000. So that's how much I need to have saved up. That is A, okay? And what I want to find is the principal, right? So far, everything we've been doing has been finding future value. Right now, it's the other way, where I know what I want it to be in the future. I want to know how much I need to have right now, okay? So we're going to be trying to find what the principal is going to be if this is its future value. Okay, so we've got a CD here that's giving us 4% interest, which, remember, we got to write as a decimal, so that's 0.04. And I'm going to be saving it over a 5-year period. So my T is going to be 5 years. And I need to know the number of compounding periods per year. So as I look at this, it says compounded monthly. So keep kind of using this same number because it is so commonly used, right? So our in here, the number of times we're getting that interest is 12. Okay. So our principal is the future value divided by 1 plus r over n raised to the n times t power, and I'm just going to kind of put those implied parentheses right there. All right, so our A is 60,000. And then on the bottom, I've got 1 plus our r here is 0.04. We got to write that as a decimal. Divided by my number of compounding periods per year, which is 12. And then this is going to be 12 times 5, right? Because it's over 5 years. Just putting parentheses around that. Okay, well that is a pretty big calculation there. So let's try to deal with that in smaller pieces. I'm just going to deal with what's inside the parentheses here first. So that 1 plus 0.04 divided by 12 will be 1.00333333, repeating. And then I'm going to raise that to the 12 times 5 power, which is the 60th power. Okay, so I'm going to do one more in-between step here, make sure I've got this number correct. So I'm going to raise that to the 60th power here. And I get 1.220996594. I might as well use all my digits here because as I do these calculations with big numbers over long periods of time, rounding really messes up my final answer. So I'm going to take 60,000 and divide it by that value of 1.220996594, and I get $49,140.19. Okay, so it's kind of a tedious calculation, but it's not that terrible. I think really if you approach it in pieces like I have here, you're much less likely to make mistakes. And, you know, realistically, as we're looking at this, 49,000, of course, is way better than just needing $60,000 at that point, so we're making that compound interest work for us instead of against us. And that's how we approach a problem like this.